Namaste to all my dear students. Today we are starting very important branch of physics, that is nuclear physics. In this course, we are going to learn the basics of nuclear physics. Before doing anything, we must have a general idea about it. Not only idea, but also its important implications and applications. Why should we study nuclear physics? In what way it is going to enrich our knowledge? What are its benefits to our society? So first of all, we should know that what is nuclear physics? Nuclear physics is the branch of physics that studies the structure, properties, its constituents, and interactions of the atomic nucleus. In nuclear physics, we study all the phenomena associated with the nucleus. Now, what are its important applications? Why should we study nuclear physics? Nuclear physics is an interdisciplinary subject which finds manifestations in different fields. First and foremost field is energy sector. We all know that enormous amount of energy is released in nuclear reactions. And the most famous and well-known nuclear reactions are nuclear fission and nuclear fusion. Nuclear fission is carried out in nuclear power plants. On the other hand, nuclear fusion occurs in the stars or the sun. This nuclear energy is also used for muon catalyzed fusion, heavy ion fusion, transmutation of waste from nuclear power plants. Next is environment science. As we know that environment science is also an interdisciplinary field in which many sciences converge and contribute at their own level. Nuclear physics is useful in studying the radon level, waste cleanup, and groundwater. And last but not least, climate change. Climate change is a very hot topic, and scientists or researchers are devising new strategies to mitigate the problems associated with climate change. Now, next is material science. The role of nuclear physics is diverse in material science also. In material science, nuclear physics is used in ion implantation, wear testing, radiation damage, and various nanostructures. Next is art and architecture. This is quite interesting that nuclear physics have also an aesthetic aspect. It's very wonderful that nuclear physics finds applications in art and architecture. How nuclear physics is used in art and architectures? We know that by estimating the amount of radioactive element, we can determine the age of the fossils and architectural structures also. This is very well known method which is called radioactive dating. Next is medical science. Nuclear physics plays a vital role in the biomedical field. The nuclear radiations are very helpful in MRI, that is magnetic resonance imaging, PET, PET, positron emission tomography. Next is radiation effects, radioisotope productions, cancer therapy, biophysical modeling. Next is WMD. It stands for weapons of mass destruction. Weapons of mass destruction. Nuclear weapons are the most powerful and violent devices. Within a fraction of seconds, large amount of nuclear potential energy is converted into kinetic energy. Along with this kinetic energy, violent shock waves are also produced. We must have heard about atom bomb, nuclear bomb, etc. A nuclear bomb can destroy a city within no second. It's very destructive. Its destructive nature causes many times geopolitical tensions and have potential to annihilate the entire world. Oh, that's really very attractive and important branch of physics, astrophysics. In astrophysics, nuclear physics plays an important role in understanding the origin of the chemical elements and isotopes in the solar system. It is also used in understanding of cosmic sources. What are cosmic sources? Like stars, supernova, and binary star interactions. Now let's take a brief look at historical background of nuclear physics. In 1896, Henry Becquerel discovered radioactivity. Basically, he discovered uranic rays accidentally. And this was the starting of new discipline, which is nuclear physics. In 1897, Sir J.J. Thomson discovered electron while studying cathode rays. It means atom is not an elementary or fundamental particle. It has an internal structure. After a few years, Marie Curie and her husband Pierre Curie discovered radioactive polonium and radium. Also, alpha, beta, and gamma radiations were also discovered during these years. And in 1903, the Nobel Prize in Physics was awarded jointly to Henry Becquerel, Marie and Pierre Curie for their work in radioactivity. You see, just in 7 years, this field has got a Nobel Prize. In 1905, the most famous physicist, Albert Einstein, formulated mass energy equivalence law. According to this law, E is equal to mc square. That is, energy and mass are interconvertible. They are not separate entity. They are interconnected with each other. They are not inseparable. Yes, in 1911, Ernest Rutherford's scattering experiment led to the discovery of the nucleus. The nucleus. This was a path-breaking event in the annals of history. It not only opens the new fields of the research, but also changed or even redefined the world geopolitics. In 1913, Niels Bohr used classical and quantum mechanics to explain the dynamical model of hydrogen atom. In 1932, James Chadwick discovered neutron, and scientists were able to determine the binding energy of the nucleus. And this calculated binding energy was found to be in agreement with Einstein's formulation. In the same year, in 1932, Anderson discovered positron. So in 1932, neutron and positron were discovered. So this was all about the historical background of nucleus and its constituent. Now, where is this so important entity that is nucleus is located? Oh, our universe is so beautiful, but also unknown to us. We have very little knowledge about it. Anyhow, we believe that our universe consists of 68% of dark energy, 27% dark matter, and the rest 5% is regular matter. I am not discussing about it, otherwise it will unravel another story. For the time being, we have to search nucleus. So it is advisable to focus on the main target, which is the nucleus. Many things about dark matter and dark energy are unknown to us. What is important for us? That is regular matter. This regular matter consists of 4% out of 5%, 4% contains hydrogen and helium, and see, less than 1% constitutes stars, and less than 1% rest of the thing. It's quite interesting. We know something only about 5% regular mass matter. Now, this 5% regular matter is further classified into 5 states: solid, liquid, gas, plasma, and Bose-Einstein condensate. We all are familiar about the basic difference between first 3 states, that is, what is solid, what is liquid, what is gas, what are the basic differences between these 3. We all are familiar, and we encounter in these all things in our daily life also. Now come to fourth state of matter. What is plasma? Have you seen it? Let's see. What is plasma? It is nothing but a gas of ions. It is gas of ions, which consist of only positive and negative ions. It is a gas of positive and negative ions, nothing else. Have you seen this state of matter anywhere? Have you seen this state of matter anywhere? Yes, maybe. Plasma is formed during lightning or in the Earth's ionosphere or magnetosphere. Also, plasma is also formed in the interior of the sun, solar corona. Then, last stage, fifth stage is Bose-Einstein condensate. Oh yes, Bose-Einstein condensate. B stands for Dr. Chandra Bose, a famous Indian scientist. E stands for Albert Einstein. Bose-Einstein condensate. What is this? What is Bose-Einstein condensate? See, Bose-Einstein condensate is a group of atoms and that group of atom is cooled to a very low temperature. At such a low temperature that atom cannot move relative to each other. And what is the order of this low temperature? This is very close to the absolute zero. At such low temperature, the group of atoms have almost no free energy to move. All the atoms of this group fall into the same quantum state. They fall into the same quantum state at such a low temperature and low density. And they are indistinguishable from each other. They are indistinguishable from each other. All these 5 states of matter, of regular matter, consists of molecules. And molecules, there are different types of molecules. They are classified according to the geometry, size, shape, and other properties. Anyhow, each molecule is composed of 2 or more atoms. Such type of molecules we have seen. In an atom, there is positively charged nucleus and electrons revolve around it. Yes, like this. In an atom, there is positively charged nucleus and electrons revolve around it. So, this is nucleus which located at the center of the atom. This nucleus is very heavy and almost all mass of the atom is carried by it. It is positively charged nucleus. It lies at the center of the atom. It's a very interesting and powerful entity. The nature's strongest force, which is called strong force or nuclear force, operates within this nucleus. Many more beautiful things lie in it. The study of nucleus led to the discovery of another new branch of physics, which is called particle physics. In particle physics, we came to know more than 200 elementary particles. More than 200 elementary particles were discovered after the discovery of nucleus. That was totally a new word, a very wonderful word. Now this is comparative scale. Now this is comparative scale only to understand the relative size of different objects which we know till date. Yes, this scale is just for comparison and it is in meter. The size of object is taken in meter. It ranges from 1 to 10 raised to power 27 meter. Now we can see that the size of our universe is 10 raised to power 27 meter. Our Milky Way is 10 raised to power 21 meter. The distance between the sun and the earth is of the order of 10 raised to power 11. A ball or human being is of the order of only 1. Then moving to the left side, red blood cells are of the order of 10 raised to power minus 6 meter. Then atom, yes, it's atom. The size of atom is 10 raised to power minus 10 meter. It is 1 angstrom. And this was determined by Sir J.J. Thomson for which he was awarded Nobel Prize. Then last but not least, there is nucleus. The size of nucleus is 10 raised to the power minus 15 meter. 10 raised to the power minus 15 meter. Very small. Now, if we compare the size of a nucleus and a universe, then we can see that our universe is 10 raised to the power 42 times larger than the nucleus. So the size of a nucleus is only 10 raised to the power minus 15 meter, and size of atom is 10 raised to the power minus 10 meter. Now, let's have a talk about atomic models. As we know that Sir J.J. Thomson discovered electron in 1897. After a few years, that is in 1904, Thomson proposed atomic model which is known as Plum pudding model. This was the first atomic model ever proposed. Thomson proposed that negatively charged plums are embedded in a positively charged pudding. Now, how can we visualize this plum pudding model and why it is called so? Now, if we try to visualize it, then we can consider a cake in which dry fruits are embedded. Now, dry fruits are taken as plum electrons, and rest of the cake matrix is taken as positively charged pudding. Basically, what is pudding? It is a sweet food which is a mixture of bread flour, rice, eggs and milk. So this is some sort of sweet dish. This was a famous model proposed by J.J. Thomson, which is called plum pudding model. But in 1911, after 7 years of plum pudding model, in 1911, Ernest Rutherford challenged the plum pudding model. Thomson's plum pudding model fell off due to various shortcomings. Main shortcomings were that it was unable to explain the deflection of alpha particle from gold foil. That is, it said nothing about the existence of the nucleus. And more serious drawback was it was unable to explain the hydrogen spectrum and also light spectrum. Due to these major shortcomings, Thomson plum pudding model fell off rapidly. In 1911, Rutherford performed gold scattering experiment and concluded that positive charge is not continuously distributed, but it is confined to a very small volume. It is confined to a very small volume of the nucleus. It is not distributed like plum pudding model. This positively charged entity was named as nucleus, and Rutherford was successful in determining the size of the nucleus, which is 10 raised to the power minus 15 meter. This model was also not absolute model. Rutherford model has many shortcomings, and in 1913, after just 2 years, a smart scientist Neil Bohr, agreed to the existence of the nucleus inside the atom, but he gave more information about the atom. His model came to known as planetary model of atom. Planetary model of atom. What he said? He said that as the planets revolve in their fixed orbits around the sun, the electrons like planet also revolve in fixed orbits around the nucleus like the sun. This model was a combination of classical and quantum mechanics. And this model explained the experimentally observed hydrogen spectrum, which was the major success of this model. Anyhow, this model was also not an absolute model. It has also many shortcomings. So, this was the introductory lecture on nuclear physics. We will meet soon to discuss some serious and deeper topics on nuclear physics. Thanks a lot for watching and listening. Thank you. Thank you very much.